All right, here we are for module 6, walkthrough of the owls. So, question 1, classification of alcohols. So, here we have a model. This is a carbon, 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 and then an OH group. So basically, it looks like this. So this OH group is connected to a carbon and only one other carbon is connected to it. So this is a primary alcohol. All right. So primary. All right. Let's see what other examples here. Oh, this is a fun one. All right. So it looks like this one's in a ring. Move the model here. So I see this and an OH group. So the carbon that the alcohol group is connected to two carbons. So this would be a secondary. There we go. Let's see if we can exhaust all of our options here. If there happens to be a tertiary, yep, perfect. All right, so this one, I see an OH group, and then I see it come down to here, and then it looks like it goes to three different things here. So OH group, main chain, and a methyl group. All right, so because the carbon that's connected to the OH group is connected to three other things, it's going to be a tertiary. So we got an example of all of them. All right, next we have naming alcohols. So I know it's an alcohol because I'm in the naming alcohol sections, but because it has this OH group, that's the characteristic of alcohols. And so they have the ending ANOL, anol. All right. So my first step is to count, well, my first step is to identify my functional group, right? Second step, count carbons in the main chain. So I can number left to right, 1, 2, 3, 4, or right to left, 1, 2, 3, 4. I want to put the OH group at the lowest possible carbon, so I'm going to want to number right to left. All right. So I have a, let me put this below. I have a butanol because 4 carbons in the main chain and an alcohol group. You need to tell the audience that it's at carbon 1 because Al likes when we do that. And then I need to tell the audience about this carbon here. It's a 1 carbon branch coming off of carbon 3. So 1 carbon branches are methyls and 3 in front of that. So let me retype it to make it look prettier. So 3 methyl, 1 butanol. Nice. All right, let's do another example. So here I see my main chain here and then my OH group. So it looks something like this. So alcohol group, still anol. That's an O. All right. 1, 2, 3 carbons in the main chain. So it's prop. And then I need to tell the audience what carbon it's coming off of. It's coming off of carbon 2. Even if I numbered the opposite way, it'd still be coming off of carbon 2 just because this molecule is symmetrical. So 2 propanol. All right. So we did alcohols. Here's drawing alcohols. So here's a fun one. This is probably one that's some of you, if you haven't finished all your owls, you haven't tackled this one. So my first tip is to draw it on paper before you even try to draw it on the screen. All right. So we know it's an alcohol for a couple reasons. One, we're in the alcohol section, but it also ends in ANOL. We know that there's 4 carbons in the main chain. So 1, 2, 3, 4. All right. This 1 tells me that this alcohol group is coming off of carbon 1. So off of carbon one, I'm going to put an alcohol group. Next, it tells me that there's a methyl group off of carbon three. So I'm going to draw a methyl group off of carbon three. So I'm looking to build a molecule that looks like this. The thing with a drawing is that you have to build out all your carbons first and then override them with your other uh, elements. So here's the single bond tool. This is what we're going to use. We're going to come over, we're going to hover over the C, click it once, and it pops out another carbon. Click it twice, pops out another carbon, 3 times, and now I have my main chain. So now I'm going to go add this alcohol group. So I'm going to come back over, hover over carbon 1, hit it again, but it pops up a CH. I'm going to come over to this tool, which is the oxygen tool. I'm going to click down on it and then hover over this last C. It's going to change it to an OH. This tool takes care of all the oxygens for us, which is nice. All right, so now I have everything but that branch. I'm going to come back over to the single bond tool, hover over carbon 3, and put that branch. Ta-da! Oh, let's do another example. Ooh, this is fun. All right, so cyclopentanol. So I have a 5-member ring, so a pentagon. And then it doesn't tell me which carbon our alcohol group is coming off of, but it doesn't matter because no matter where I put this alcohol group, it's going to be carbon 1. So I'm just going to put it on top. Just seems reasonable. So with rings, you actually have a tool for basically every shape ring you need. All right, so there's a few of them here, but you can hit the drop down menu. Here's my 5-member ring. So I'm going to hit this and hover over this dot. Click there. Automatically does all of this hard work for me. My next step, try to zoom in, is to build this OH group. But first, I have to build everything as carbon. So I'm going to hit the single bond tool, hover over this top carbon, and it becomes a CH3. I'm going to hit the oxygen tool and overwrite it to be an oxygen. Boom. All right. Next, we have some solubility practice. So compare the solubilities. So you need your chart from the reference sheet. I know from my memory that an ether is more soluble than an alkane. I know this is an alkane because it ends in ANE. All right. I also know from my chart that a alcohol, ANOL, is much more soluble than an ether. So again, more soluble. All right, so there's some examples there. All right. Looks like we're doing the same thing now with boiling point, which follows the same trend, right? So an ether is going to be a higher boiling point than a hexane. Ooh, this is interesting. Is it similar? Okay, that one, that must just be the number of carbons, just happens to be similar. That's crazy. All right. Well, if you get that little message, what to think. All right. Looks like I have an alcohol, an alkane. So here's my alcohol, an alkane, and it looks like this is an ether, maybe an ester, but we can group them as the same. So alkane is definitely going to be the lowest boiling point. Alcohol is going to be the highest, and ether is going to be intermediate. There we go. All right. Let's practice this one. So, wow. Okay. So, uh, if I haven't said it already, red's oxygen, and this gray is carbon, gray. All right, white's hydrogen. So it looks like I have a C double bonded to an O bonded to an OH here. Okay, so the molecule has a carbonyl carbon. A carbonyl carbon is when you have a carbon double bonded to an oxygen. So yes, true. And this is a carboxylic acid, which has this representation. R, meaning the rest of the molecule, COOH, right? Because COOH. All right, and this compound is a carboxylic acid. All right, let's see if we get another one. Okay, here's one. So also has a carbonyl carbon, right? A C double bonded to an O, so true. This molecule would be this guy, where you have the rest of the molecule, a carbon, a hydrogen, and an oxygen. So that's designated here. And this is an aldehyde because that C double bonded O is on the end of this chain. All right, let's do this last one. Yeah, it's a ketone. Good. We get an example of all of them here. All right, so we have this C double bonded to an O, so true, we have a carbonyl. This is going to look like this, right? Where we have the rest of the molecule, the rest of the molecule. This one happens to be symmetrical, but R prime or R asterisk can be however many different amounts of carbon. And then you have that C double bonded to O in the middle. And this is an example of a ketone. All right, so now let's name these. So I'm naming aldehydes. All right. I see my C double bonded O at the end of a chain. So aldehyde, I know the suffix is ANAL. All right. So I want to make the aldehyde is one of them that always falls at carbon 1. All right. So I'm going to call this carbon that I just circled over here carbon 1. Then we have 2, 3, and 4. So this is one of my favorites when it's a. All right. So 4 carbons in the main chain. So bute, and then um ANAL for aldehyde, so bute and anal. All right, so that takes care of the main chain. This one, since it's always at carbon 1, I don't need to tell the audience what carbon it's coming off of. Next, I gotta take care of those branches. So I have a methyl branch here and a methyl branch here. So I have 2 methyl branches. So this is a dimethyl. So I put that up here. And I just need to tell the audience what carbons they're coming off of. So they're coming off of carbon 2 and 3. I don't know how it got so big there. So 2, comma 3, hyphen dimethyl butanal. Voila. All right. Here's another one. I'm going to orient this if I can. Here we go. All right. Trying my best here. This is hard. All right. So I see this. So I'm going to redraw that. So 1, 2, 3, 4, 5. 2, 3, 4, 5. All right. So ANAL, because it's got that carbon double bond to an oxygen at the end of a chain, and it's always at carbon 1, so that's why I numbered from left to right automatically. It's got 5, so it's pent, and there's no branches. So this guy is happy as he is. There we go. All right, same thing for ketones. Now ketones is that same functional group, but now in the middle. And ketones have the ending ANONE, NO. So I want to make the functional group the star of the show, so I'm going to number here 1, 1, 2, 3, 4. So I know it ends in ANONE, bute, because there's 4 carbons in the main chain. This one I do need to tell the audience what carbon that's coming off of. So it's coming off of carbon 2, the functional group, that C double bonded to an O. And we also have a branch to take care of here. It's a 1 carbon branch. It's a methyl. And it's coming off of carbon 3. So 3 methyl to bute, A-N-O-N-E. All right. Ooh, I like this one. I'm getting some good examples for these videos. All right, so we have a ketone in a ring. All right. The ring is six-membered ring. So it's going to end in A-L-N-E. Six-membered, so it's going to be hex. And then cyclo in front of it because it's a ring. Now, it's implied that this is going to fall at carbon 1, no matter what. So I can just call this cyclohexanone. Yep. All right. Okay, here's another one that y'all probably have avoided. Drawing alkanes and I'm sorry, drawing aldehydes and ketones. So with the other drawing, I like to draw it first on paper before I try to draw it in the program. All right, so 2-methyl-propanol. So this indicates an aldehyde, right? So I know it's going to have a C double bond to an O at carbon 1. It's got 3 carbons in the main chain, right? So 1, 2, 3, with that first one being a C double bonded to an O. All right, so that's my main chain with my functional group. Next, I have a branch, a methyl branch, so 1 carbon branch coming off of carbon 2. All right, so I have something that looks like this. So now I'm going to try to draw in the program. I'm going to hit my single bond tool. I'm going to go 1, 2, 3. So now I've made my my parent chain. I'm going to add that functional group. This time, I'm going to come in for the double bond tool, hover over that first carbon, and it's going to give me a double bond to a second carbon. I'm going to override that second carbon by coming up here and choosing oxygen and clicking on that. Next, I'm going to add my branch by clicking the single bond tool again, hovering over this second carbon and clicking. Ta-da! All right, we'll do another one. Ooh, we got the cyclo again. All right, so cyclopentanone. All right, so pent 5, and it's in a ring, so it's a pentagon. And then just like when we were named the ketones that were a cyclo, uh, it always is implied that that's at carbon 1. So I'm just going to make it the top. Seems logical. So I'm going to come down here. Oh, now they move my uh, pentane group over here, probably because I was using it. All right, so I'm going to click on this guy. Automatically going to give me this. Now I'm going to click on the double bond tool, hover over that first carbon, click, override for an oxygen, click, ta-da. Beautiful. All right. All right, so here we have physical properties of aldehydes and is this ketones as well? Yep. All right, so here we have an alkane because it's all carbons and hydrogens. All right, here looks like an alcohol. Here's a ketone. All right, so again, I'd go back to my chart, but I know that alkanes would be the lowest, alcohols would be the highest, and ketones would be intermediate of this group, of this pairing. Great. I'm going to move on. All right, naming carboxylic acids. All right, so I know it's a carboxylic acid because that's the question we're in, but also because it's got a C double bonded to an OH, same carbon double bonded to an oxygen. I think I just said a bunch of gibberish. Okay, so this functional group, carboxylic acid, all right, has the ending anoic acid. Okay, so this is also one that's always at carbon 1. So I'm going to start this here. 1, 2, 3, 4. And it looks like, there we go. All right, just a branch here. So what I see is this. So 1, 2, 3, 4, and then a branch here. So ends in enoic acid. This is the one time where the IUPAC naming accepts spaces between enoic acid. 4 carbons in the main chain, so bute. I don't need to tell the audience where it is because it's coming off of carbon 1. And then, but I do need to tell the audience about this methyl group coming off of carbon 2. So I'll say 2-methyl. 2-methyl enoic acid. Oh, it doesn't like that. What did I mess up here? 1, 2, 3, 4. Bute. Enoic acid. Coming off carbon 2. Oh my gosh, I'm blind. There's another branch right here. Okay. So 2, 3, and I gotta add a di there. There we go. Wow. All right, here's another one. This is a fun one. All right, so this is just a 2 carbon, a 1, 2 with no branches. So 2 carbon is F, and then enoic acid, because this is a carboxylic acid, and no branches. So just F enoic acid. There we go. All right, let's draw. All right. So 2,3-dimethyl butanoic acid. All right, so I have this at carbon 1. I know that's my carbon 1. 4 carbons in the main chain. So 1, 2, 1, 2, 3, 4. And then my carbon 1, oops, it's going to have this. Right? Now I have some branches. Is this just like what we just named? Or yeah, I think it is. So we have 2 methyl branches, one of them coming from carbon 2 and one of them coming from carbon 3. All right. So to draw this, single bond tool, make my main chain. 1, 2, 3, 4. All right. Now I'm going to do one more. This is going to eventually turn into my OH. I'm going to do a double bond. That's going to turn into my doubly bonded O. Now I'm going to override with my oxygen. So there's my OH. Here's my double bonded O. Now I'm going to come back to my single bond tool, do a methyl group at 2, 3. All right. All right. Are these the same? Huh. Okay, we'll do this one. All right, 3-methyl butanoic acid. So same thing, 4 carbons in the main chain. 1, 2, 3, 4. That first carbon is going to be my carboxylic acid. And I'm going to have a branch at carbon 3. So single bond, 1, 2, 3, 4. All right, I'm going to do 1. That's eventually going to become my OH. That's going to be my double bonded O. Grab the O tool, override, so that way they look right. Single bond tool to add the branch. Boom. All right, last question. All right, so carboxylic acids are always the highest. They're the highest on that chain. So here's my carboxylic acid, so match that one. Ketones would come next, and aldehydes would have the lowest. All right, so hopefully that helps you. We're gonna